Hello, hello, hello. What's up to you all, Mindsetters? It is a lovely Monday, our Triple M day. You know what that means. It's Mindsetters Maths Monday. You know it, Dina, by now, hey? It's
Triple mind maths.
Dina. Okay, we'll start afresh. It is our Triple M day. Mindsetters Maths Monday, or Mindsetters Maths on Monday. My name is AB, and Dina is also in the house. Dina, how are you?
Very well, AB, and I'm ready for some grade 11 maths.
I'm ready too. What are we doing?
We're going to be looking at analytical geometry, some of the topics that you'll be asked in the paper 2 for this examination. So get ready.
So is this some kind of scope?
Scope?
Yeah.
Why?
Oh, I'm just saying, because you were saying things that might come on their exam. You know what?
Definitely.
The mindsetters have been asking for a scope, and I keep on telling them these shows are there to help you guys as guardians. We're never just gonna give you on a silver platter a scope. We don't have a scope, unfortunately. The only scope is revising with you guys and helping you on key topics. That's what we do, right, Dina?
We don't have internet connections to all the schools to know what the scopes are for the various schools. So, yeah,
That's illegal.
bear with us. It's all about revising together for that practice of that final grade 12 paper, which you'll be writing next year sometime.
Exactly. Well, you guys are pre-matriculants, and let me tell you, to hashtag walk with us, all you need to do is to join me on Facebook, chat with me on facebook.com/LearnExtra. You know it by now. You can share the page, tell all your friends about the page, but most importantly, we want you guys to send us your questions on Facebook during this show, and we'll try by all means to help you guys, and you can also help other mindsetters. That's very important, guys. Let's help one another on the page. It shouldn't just be you asking your questions, but also try to help other mindsetters. On Twitter, you can follow us at LearnExtra, and remember, we do have the notes links on Facebook, which is your viewing option and your download option. And lastly, we have the test yourself link. 2 questions whereby if you answer them correctly, you stand a chance of winning this awesome Casio calculator. Our last week's winner will be announced during the show. One last more thing, guys. We have the Nokia Mobile Mathematics, and your code as grade 11s is 0JRN. More details will be on Facebook. It is a cool app. You can challenge one another. It's all about mathematics. Also, let's see who's on top of the rank and who is the best mindsetter, a best mathematician today. Dina, back to you.
Wow, AB can really talk. He should be the next Minister of Education, don't you think? Let's have some messages.
I vote.
Okay, everybody, it's analytical geometry time. Let's get straight to it. Get out your pen and paper and let's work together on the following various aspects of analytical geometry, and let's see what this lesson's all about. Right, we are going to work through examples to show us the various key concepts. I'm not going to go through the theory as such, just to remind you that the 5 main topics that are within this analytical geometry is your gradient, your parallel lines, and your perpendicular lines, the equation of a line, the distance of a line segment, as well as finding the midpoint, and that very important grade 11 topic of inclination. And then we must always revise the properties of the various geometrical figures, especially the quadrilaterals. There is a challenge question, which you'll have to carefully draw. I would suggest that you always are accurate with the drawing of the diagram, so you can verify whether your answers make sense. Firstly, A is -3,6, B is 6,4, C is 2, -4, and D is AB. And those are the vertices of a parallelogram ABCD. And you have a couple of questions to answer. What are the coordinates of either midpoint, the coordinates of D, the fourth vertex, the equation of the diagonal, the inclination of AC, as well as the sides of DAC. So those we are going to look at the last segment of today's show. So for now, we'll get you working on that. And as a summary, just that we've got the distance formula in front of us. So we've got the distance formula, very important. It's the square of the segment is the difference in x's, the difference in y's. It really does remind us of Pythagoras, because that's really what it is. If you have a diagonal, you are going to take the Pythagoras theorem, and you're going to say that it's this side squared and that side squared, and that is the difference in x's, and that's the difference in y. So there's always a Pythagorean calculation involved. The midpoint is always the sum of the coordinates. It's the only place where you're going to sum the coordinates. Then the gradient of the line is always the difference in y divided by the difference in x. We can talk about our rise over run. Okay, I always work with my students that you first rise and then you run, so we know what's in the numerator and what's in the denominator. And then if we are given that two lines are parallel, their gradients are equal, and if we're given anything about perpendicular lines, then the product of the gradients is -1. And then that very important concept that the inclination is the angle that a line makes with the x-axis, and it's always defined by gradient equals tan of the angle. And finally, we can work with the equation of a straight line by taking the difference in y's is equal to the gradient multiplied by the difference in x's. And that is quite a quick way of getting y equals mx plus c. Okay, so let's look at the first question, which comes from the Macmillan book, Clever Keeping Maths Simple. Clever Keeping Maths Simple, right. So always at the outset of any coordinate geometry, you need to read through the information and make sure that you've translated it into a graphical format. So we have in triangle ABC, the coordinates of vertices A and C are -4, 6, and 8, 2. So there's A, there's C, and we're already looking at, it's almost like a mathematical GPS. We're looking at the positioning of these coordinates, second quadrant, and we have first quadrant. D is a point, is the midpoint of BC, and E is the midpoint of AB. So we have that segment from D to C is equal to that segment from D to B, and F is a point, 6K, where that line FC is parallel to that line AD. So we've got all this information. It's all been translated into a picture. So I can actually leave the information out and now just focus on my diagram. Okay, and analyze what's happening over here. If I have parallel lines, then what do I know? I've got equal gradients. I have a midpoint. So I certainly can work out the coordinates of B by using my midpoint. And I may just be interested in another midpoint over here, but we'll see how the questions go. So first question, determine the coordinates of B. So I try and identify what is special about the coordinates of B. And we already said earlier that it lies on a segment where the line has got a midpoint. So those two segments are the same. So if you are calculating the midpoint, you'd be working with those two coordinates, adding them and getting that value. Now we do exactly the same thing, and we would say that x of B plus my x of C divided by 2 should be equal to my midpoint, which is 0. So I now have, just gone a bit too far, there we go. We've got x of B plus 8 divided by 2 is 0. So we multiply 2 on that side, and we get x of B is equal to 0 minus 8. So we get x of B is -8. Okay, now just check your solution. Just substitute -8 in here. Then -8 plus 8 is 0, divided by 2 is 0. So it makes sense. So it's a matter of just checking. And then we've got my y of B plus y of C divided by 2 is equal to -2. That would make y of B -4 minus 2, which would be -6. Again, let's test that. -6 plus 2 is -4, divided by 2 is -2. So B is definitely the point. -8, -6. Okay, using the midpoint in reverse, because sometimes if we don't have the midpoint, we can go calculate one of the endpoints. So being able to calculate one of the endpoints. Give the coordinates of E the midpoint of AB. Okay, so now that I have B and A, I certainly can work out E by using the midpoint as well. So this point over here, if that is equal to that, would be -4 and -8 is -12 divided by 2 is -6. So that would be -6. And my x value would be, or my y value would be 6 minus 6 is 0. So it's actually 0. So that would be the midpoint. And I like to talk about A and B. So x of A plus x of B divided by 2 is equal to x of E. And that was your -6 and divided by 2, which would give me 0. So that's my x value. What's the y value? Y of A plus y of B is equal to y of E. And let's see what those values are. You've got a 6. Actually, let's just look at this -8, -4. Okay, I'm jumping the gun here. Let's just look at these x's. X of A is actually -4. And x of B is -8 divided by 2. So that gives me -6. And then the y values are actually our 6 and -6. So it would be 6 minus 6 is 0. And that would be my point E is -6, 0. It's actually on the x-axis. Okay. Prove that ED is parallel to AC. Okay, how can we prove that this line is parallel to that line? Okay, and I would like you to do it analytically, which would mean using some of our summary notes, and our summary notes were up here, actually right down here. Okay, what did we find? And whenever you wanting to draw on knowledge that you've done around analytical geometry, always come back to the summary notes. We saw here that when lines are parallel, what do we know about their gradients? The gradients are the same. So that's what we're going to go and look at, is if lines are to be parallel, then what I'm really going to be doing here is trying to prove that the gradient of ED must be the same as the gradient of AC. So if I do that, if I show that those lines have got equal gradients, then I will be able to prove that the lines are indeed parallel. So let's work with gradient of ED. Now, grade 11s, with this kind of work, it's quite important that you focus on getting the accuracy right. So that would be a -2 plus a 0, or -2 minus 0 actually. -2 minus 0. And D is -2 minus 0 and 0 plus 6. So we get a 0 plus 6. So I get that this gradient is -1/3. Okay, and then the gradient of AC is what? AC is 2 minus 6 and 8 plus 4. So 2 minus 6 and 8 plus 4. So I get -4/12, which is -1/3. Well, that's what we said. If we could show that, we've actually got that the gradients are the same. So your conclusion would be, therefore, ED is parallel to AC, since the reason is the gradient of ED is equal to the gradient of AC, which is equal to -1/3. Gradients are equal, lines are parallel. Show analytically that AC is indeed twice of ED. Why would AC be twice of ED? Now, when you do coordinate geometry, we always say that if in a triangle we have a line that joins 2 points, 2 midpoints, there's the midpoint, there's another midpoint, then that line will be parallel. So we've just been able to show that it's parallel without using any of the Euclidean geometry. However, if we were to show that this line is equal to half of that big line, we would just use Euclidean geometry as a result. However, analytically, we would need to show what is the distance of AC. So I would work with AC squared as the difference in my x's. So it's 8 plus 4, which is 12 squared, which is 144. And I'm then taking 6 minus 2 is 4 squared, which is 16. So I get 160. As AC, I get 100 times 16, so that's, or 10 times 16, so it would be a 4 root 10. Now, if I work with ED squared, what would that look like? 0 plus 6 is 36, and we've got a negative 2 plus 4, so we've got a root 40. So it gives us ED as 10 times 4, so it's 2 root 10. And now we can work out what is the ratio of AC to ED. So AC to ED is in a ratio of 2 to 1, and so you've proved that AC is twice of ED. And by using that, the distance formula, we've been able to show that certain ratios exist between those line segments. And that was question 1, AB.
Nice one. Nice, short and simple. There was a question actually based on that. Where did you get your 8?
This negative 8.
Yes.
It actually says over here, you take the sum of the two endpoints. It's the midpoint formula, 8 plus this x value of b that you didn't know, divided by 2 must give you the middle value, which is your midpoint, which is 0, times by 2, and then you took away the x of c, which was negative 8. So it was basically substituting into this formula and solving for the unknown, which was this value here.
Awesome. Well, I hope, Rocco, you got that one right. We'll take a break, my sisters, but remember, during this break, you do have the challenge question that is posted on our Facebook page. And your questions, I'm waiting for them. I'm here to help you guys today. We want your questions. So see you after the break. Welcome back, my sisters. Now you've got that chance today to enter for the Test Yourself competition, whereby you stand a chance of winning this awesome Casio calculator. And I'm about to announce last week's winner, Dina. It's so exciting that we're giving away these during exam time. So it's good buddies. It's a must-have, I must say.
I must have, because I've looked at my students' calculators and they're missing the writing. So I don't know how they know which button it is. So I'm very glad you are making somebody very happy to get this brand new calculator. Fantastic.
Awesome. Let's announce our winner. Drum roll, please. And our winner is Sitela Tola Ezo. Congratulations to you, Sitela Tola Ezo. This is coming your way. More details will be on Facebook on how you can enter Mind City. So all the best. And the challenge question is waiting for you.
Awesome. I hope that you've all been able to give it a go and tried it out, and we will have a look at the answer in our next segment, and I'm sure we will make somebody very happy if you can answer that. Right. We've just done one question, and it had 5 little parts, but I've got a couple more questions to go on the same diagram. So currently, we looked at that this was the midpoint. We also looked at that this was the midpoint on the side, so there was a midpoint here, and there was a midpoint there. We looked at what these coordinates of B were, we looked at the coordinates of E, and now we're going to carry on. We're going to prove that AD is perpendicular to BC. Now, grade 11s, what do we do if we would like to show that two lines are perpendicular to each other? Always try and translate what that means in an actual formatted version of the statement. So I'm not going to go to the diagram and try and show that those lines are meeting at 90 degrees. I'm going to be showing something about the gradients because I am working with my information on an analytical basis. So I'm going to actually show that the gradient of AD times the gradient of BC, I'm actually going to show that that gradient, the product of those gradients, is equal to -1. Okay, so we now have a statement that we're aiming towards. So I would like to work out what is the gradient of AD, and that would be this gradient over here. So we would have gradient of AD, looks like we're writing mad, is 6 plus 6 is 0, divided by, got the wrong line, AD, where's AD? There's the line AD, okay? So, perpendicular to BC, okay. So here we have AD, so my change in Y would be 6 plus 2 is 8. So that would be 8. And my change in x would be -4 minus 0, which is negative 4. So that gradient, let's just keep going down, is equal to negative 2. And then let's have a look at what the gradient is of BC. And that is this line over here. So it's 2 plus 6, which is 8. And it is 8 plus 8, which is 16. So that's my gradient of BC, which is a half. Now, if I look at BC, my gradient is positive, my AD it's negative. So I do need my gradients to be different signs. Let's take the product. Gradient of AD times the gradient of BC, substitute in, what do you get? Negative 2 times a half. What does it give you? Negative a half. From that statement, we're now there. So therefore, AD is perpendicular to BC. Right, so we've looked at two of the most important concepts in analytical geometry. One, the parallel lines and how they have equal gradients, and perpendicular lines and how we look at the product of their gradients. So we look at the nature of lines through the positioning of those actual lines, or the positioning of the lines actually gives us something about the gradient. So those two pieces of information must always be at the forefront whenever you're dealing with analytical problems. Okay, then we would like to find the value of k if these lines are parallel, if those orange lines, let's actually make them a lot more visible, so let's make them blue there. That line is parallel to that line. Okay, we've just said that if lines are parallel, then their gradients are the same. So we would take the gradient of AD, ooh, what happened there? The gradient of AD, and that would be what we've just worked out, which was negative 2. And the gradient of FC would be equal to negative 2, since, must always give a reason, AD is parallel to FC. Okay. Then I can now take the gradient of FC, which would be k minus 2, divided by 6 minus 8, and that must be equal to negative 2. So k minus 2 will equal to 4, and therefore my k value must be 6. So this point over here must be the point 66. And that, when you have f as 66, you're going to have that unique position where this line is going to be parallel to that line. Okay? And then the length of BC, give you your answer in simplest form. What is the length of BC? Distance formulae for length, if we had to calculate it on the side here, BC squared would be equal to, change in x would be 8 plus 8 is 64, change in y would be 2 plus 6 is 8, 8 squared, no, that's 8 plus 8 is 16. 16 squared is 256. Something's not right here. So that would be 256 plus, and then we would get a 2 plus a 6 is an 8 squared would be 64. So that would be 320. And if we would like to get that into its simplest form, your calculator can give you that. Or you could say it's 100 times 32, so it would be 10 root 32, which would be 40 root 2. So you would have 160 times 2. So there would be 40 root 2. So you can just check that out for me if you get exactly the same thing. Right, and then we would have the area of triangle ABC. We'd also like to put some areas for triangles. We can see that ABC is made up of two right angles, and the right angles are made up of, since we have proved earlier that this line is perpendicular to that one, we've got an altitude and we've got a base, and we've just found that BC is 40 root 2. So then this green portion over here should be half of that, which is 20 root 2. And really the area of the triangle would be 2 of these half the base, which would be 10 root 2 multiplied by the height, which would be AD. And I don't know if we've worked out AD's length anywhere. We've worked out its gradient. No, we haven't worked out the distance of AD. So we would have to work out the distance of AD. Let's see if we've got some space here. So AD squared would be 6 plus 2 is 8 squared is 64, plus we have 0 plus 4 is 16. So that would be AD's length is root 80, 6, 7, 8. So it's root 80, which is 16 fives. So it's 4 root 5. And we would multiply it by 4 root 5 and then end off by saying it's 20 times 4 is 80 root 10. And I've kept it in third form just because it's just simply easier than to try and work with a calculator. Okay, so if we recap that question, it had a lot. Distance, there were lots of midpoints, there was something on parallel lines, something on perpendicular lines, something on an area of a triangle. What there wasn't something of was inclination. So let's have a look at another question where we can work out the inclination of a line. We were working with a rhombus. Earlier on I said to you, you needed to know the definitions of the quadrilaterals and know their properties. I really like to think of a rhombus as a square that you sat on, so you preserve its, the distances of those lines, but the angle at which those lines meet is not 90. It is, sorry, it's not 90, it's actually at another angle. Right, we've got A and C, and the diagonals bisect each other at M, and there they really are giving you the properties, is that this diagonal is the longer one and this diagonal is the shorter one, and the point E lies on BC. So we now have to calculate the coordinates of M, which if the diagonals bisect each other, that implies that M is actually the midpoint. And can you see that we've got those coordinates? So we can easily work out M as the sum of the x's. So 5 minus 3 is 2, 2 divided by 2 is 1, so that's 1. And 8 minus 4 is 4, divided by 2 is 2, so that point is 1, 2. So that's just the midpoint. We then have a look at the gradient of BC. Gradient of BC, all the work that you do around gradients, really you need to look for the formula and be accurate in your substitution. And if things aren't turning out the way you planned it or you're thinking, go back and just check for accuracy. It's so easy to make that slip up in the signs. Okay, so the gradient of BC is 6 minus 5. Actually, I'm talking to you about accuracy, and look what I go and do. I start with the x values. So easy to do that. So it's the difference in my y, so it's 1 plus 4 divided by the difference in my x's, 6 minus 5. So I get a gradient of 5. Does it make sense that that's a gradient of 5? That's pretty steep, that line going through the x-axis at that place. So it looks like it's about 5. So that's the gradient of BC, it's 5. So the gradient of BC is equal to 5. Then, okay, we have, see our next slide, there we go. Okay, so we've now found that M is 1, 2, and we found that the gradient of BC is equal to 5. We've also seen that these diagonals bisect each other. Okay, and we now would like to determine the equation of the line AD in the form of y equals mx plus c. Let's go and see where AD is. There is line AD. We want to know what is its equation. Okay, so here's something interesting. What do we need in order to determine the equation of a straight line? We need the gradient and we need a point. So the question is, do I know what the gradient of AD is? Okay, so AD is over here. Because my figure is a rhombus, don't forget what you were given, I know that my sides are parallel. So if I don't have 2 points, there is another way of working with the gradient, and that is through the nature of the lines. So I know that the gradient of AD is the same as the gradient of BC because, well, let's just not write that there just yet, because AD is parallel to BC since they're opposite sides of rhombus. So when you are using the properties of the figure, you must somewhere indicate that, okay, sign for because is upside down, therefore. So gradient of AD is because the lines are parallel, because the opposite sides of the rhombus. So therefore, those, that gradient is 5. Now, to find that equation of that line, I've got a gradient of 5 and I've got a point that's negative 3, negative 3, 8. So I've got a point A, negative 3, 8. Just confirm that. Yes. And I've got the gradient of AD. Gradient of AD is equal to 5. So there is a formula that links these together, and that is y minus y of the point that you have is equal to the gradient multiplied by x minus x of the point that you have. So now we simply substitute in y minus 8 is equal to 5 into x plus 3. So we are now left with y equals to 5x plus 15 plus 8 plus 23. Just to go and check if I'm happy with that. 5 yes, 23 yes is going to cut up quite high up. So it kind of makes sense. Determine the size of theta, that is BAC, and show all calculations. So where is BAC? BAC is this angle, and we need to show all the calculations in arriving at that angle. So I would say that we would need to work out with some of these inclinations in order to be able to get to some kind of angle value. And I think we'll come back after the break.
Let's do that. But I have this comment on Facebook from Asan Langobo Pros saying, Abram, the coolest thing just happened. My mom, Miss Z.M. Ngobo, and my baby sister just joined me now to see what exactly do I say is so cool about mindset. So awesome, and holla at them, holla at the Ngobos who are watching the show. The baby sister is Amanda. So a shout out to you. Well, Dina, I don't like banking, hey?
Never.
I don't like, you don't like banking either.
Never.
But this one I do like. Here's a here's a comment from Mvelo Dandane saying, well, today guys, okay, I'll get it after the break because my network is a bit slow there. I'll get it after the break. But I like this banking. Mindset is on Facebook, you have the challenge question. I'll see you after the break. Welcome back, pre-matriculants. Now, a quick reminder to you guys, we have the Nokia Mobile Mathematics app, which when you go on it, you can challenge yourself and challenge other mindsetters on it. And let's see who's the top-notch student mathematician. Let's see. Your code is 0JRN as pre-matriculants. It is 0JRN. More details are on facebook.com/learnextra. Another comment that I was looking for about banking, Dina, it's from Mvelo Dandane saying, big ups to mindsetters. I have banked my rugby practice just to be there in with you all mindsetters. You guys have helped me a lot. So that's a cool banking. It's cool. I like it.
You just banked because you didn't want to be out in the cold training for rugby.
Or you didn't want to get beaten up. I'm just kidding. No, it's cool, mindset. Welcome, welcome. Thank you. We like that. And if you're having some questions and struggling anyway, we're here for you guys. Go to facebook.com/learnextra. I'll be more than willing to take your questions. And I know that you guys have some questions and help one another. That's the spirit of mindsetters.
Super duper. Right, just before the break, we were looking at the inclination, so let's get right back to it. We were working with this diagram, and we wanted to find theta. Now, theta is nowhere near the inclination, so we need to develop some strategy here to find out how we perhaps can get to theta. Now, one thing we have in place on this diagram are the properties of this figure. And I said earlier that all sides are of equal length, so let's just put that these sides are all of equal length. If I do that, then Gray Levens, can you see what happens? That becomes an isosceles triangle, so this is also theta. So if I could work out this theta over here, then I perhaps am right there where I want to be, which is to find that theta as well. So it's one and the same theta. Now, the inclination of a line is represented by the angle that the line makes with the x-axis. So this pink line over here is making angle R1 and angle R2 with the axis, because that's the origin over there. And let's look at this line over here. Let's see this one. This line over here, it's making this angle E1, actually it's not E, it's S1, and S2 with the x-axis. So S1 is the inclination of the purple line, and R1 is the inclination of the pink line. And you'll see that if I can find these angles, and I'm going to call this angle over here S3, then I have something happening here. If I can find those angles, then S1 is the same as S3, and the sum of S3 and theta will give me this, which angle. I'm inside this triangle over here, so it's going to give me angle R1. So whenever you are given some angle that's remotely out there in an analytical picture, you need to see how does it connect to the lines that you have drawn. Because my angles are going to come from the lines as they meet that x-axis. So it's at that meeting point that I have the inclination, and it's at that meeting point that I have inclination. And you can find all the angles on the x-axis. I can find this one because it's the inclination. I can find this one because it's the inclination. So your starting point should always be the inclination. So we're going to find that by saying that the gradient of AC is equal to 8 plus 4 is 12, and negative 3 minus 5 is negative 8. So that's negative 4 over 3. Sorry. Our little calculator is not working so well this morning. Okay. It's 3 over negative 2. Okay, that's better. And I can now go to the calculator and find out exactly how big that yellow angle is. So therefore the tan of angle R1 is equal to the gradient of AC, which is negative 3 over 2. So I can find angle R1 size by using my calculator. Ta-dum, there we go. And I have that my shift tan of negative 3 divided by 2 equals plus 180, because it's an obtuse angle, is 123,7. It's 123,7. And then we'll do the same thing for the purple line. Let's see here that the gradient of BC is equal to, I think we worked that out, there it is. It's equal to 5, which is equal to the tan of the angle that the line makes, which is the tan of S1. So therefore S1, that's an acute angle, will just be second function tan of 5, and that gives us 78,7. Now somewhere along the line you would say, let's say that S3 is the same as S1, which is 78,7, and that's because they are vertically opposite angles. And then we have that angle theta should be angle R1 minus S3 as the exterior angle of triangle. Okay, so if I just print out that triangle, I'm talking about this triangle over here. If I do that, then that's the exterior angle, which is equal to the sum of the interior opposite angles, where that's just We have that purple angle. There we go, S3, and we've got theta over here. Right, so R1 minus S3 would mean that we would want 1, it's minus 123.7, so that would be 45 degrees. So theta is equal to 45 degrees. Okay, and that's the inclination. Lovely, lovely question that has got an angle within the diagram, and the way to calculate angles would be to find all the angles that lines make with the x-axis. That's our starting point. And from that, we would identify triangles in the picture. Right, I think it's time that we do the challenge question. But before we do that, are there any queries?
Yes, I have a lot of questions.
Oh, a lot of questions. And look, our diagram is so full already.
But I
Let's
think
try
we
and
can
answer.
do the challenge question and then
first.
answer
Okay,
them.
Super. Let's
Just
look
in case we don't have time.
Okay, we will do that. Okay, so the challenge question is not here. All right, so let's go another one down. Let's go there. Okay, no. Let's go one more. There we go. Yay, we got the challenge question. Right. A, B, C, and D are the vertices of a palm. Very important. We spoke at the beginning of the lesson. Properties of your quads, I must know. What's special about a parallelogram? There's a root word parallel, so it's got two pairs of opposite sides parallel. And we need to write down the coordinates of E, the midpoint. Okay, we're very good at midpoints now. Midpoint of AC would be the point, let's do it together. It would be -3 plus 2 is -1, divided by 2 would be -1/2. Okay, how many grade 11s are shouting that they got that out? And then 6 minus 4 divided by 2 is 2, divided by 2 is 1. So point E is -1/2, 1. Then we've got, if that's the midpoint, we've got to calculate the coordinates of D. It is the fourth vertex. I love this. The fourth vertex of the parallelogram. There are so many interesting ways of being able to work out that vertex, but there is one way that is very short, and that is if you work with the diagonals, because the diagonals always use the midpoint. Remember, if this is a parallelogram, fill in the properties, don't leave the diagram blank. And we now have that the diagonals also bisect each other. So E is the midpoint of AC, but if the diagonals bisect each other, E is also the midpoint of DB. And this is the beauty of this question, is that A plus 6 divided by 2 is -1/2. So in other words, A must be equal to -7. Just tidy this up here, -7. So that would be D is -7. And it would be the same thing for B. B plus 4 must give me -1. So B plus 4 divided by 2 must be -1, because that's the midpoint. It's actually equal to 1. So therefore, B is -2. Okay, so we've got the usage of the midpoint. Calculate the inclination of AC, correct to 1 decimal place. So we want the inclination of AC. Here's line AC. Where's the inclination? Where do we find it? Go and name it. There it is. And I'm going to call it alpha. So tan alpha is equal to the gradient of AC, which is 6 plus 4 is 10, and -3 minus 2 is -5. So alpha is, let's use our calculator, of -2. No, that's not what we need. We need the angle of -2. So that is 63, but it's an obtuse angle. So we've got to create an obtuse angle of 116,6. 116,6. Okay, then The last question was, calculate the size of DAC correct to 1 decimal place. DAC is DAC is that angle over here. Okay, so now we have alpha. Look at the position of theta. I've also got this line over here, AD, that is running to give me an inclination of F1. So I can work out that inclination. What would that be? The gradient of this line is the same as the gradient of this line. Did we work out the gradient of BC before? Just check. No. So we would say that F1, tan of F1 is equal to the gradient of AD. And the gradient of AD is 6 plus 2 is 8. And negative 3 plus 7 is negative 4. So that angle is F1. That can't be 6 plus 2 is 8, and negative 3 plus 7, that's a positive 4. So that's equal to 2. So that's equal to 63, 4 degrees. And having F1 as 63, 4, and that angle, again, there are two angles in the triangle. I'm going to outline the triangle. There's my triangle there. There's the exterior angle. So that alpha is equal to, or that theta is equal to alpha minus 63, which we take that minus the second function tan of 2 equals 53,1 degrees. So mine setters, how was that? Did you also get BAC as 53, 53, 1 degrees. Okay, I hope that was useful. Okay, some questions.
Big ups to all the mindsetters that got it right. Well done, mindsetters. Okay, let's have questions. How to create perpendicular bisector? That's from Garabo Maboka.
How do you calculate, or how do you create?
How do you create?
How do you create a perpendicular bisector? I would say just Google perpendicular bisector. There is a little mechanism that helps you. I won't discuss it now because it's not part of your grade 11 syllabus.
Okay, let's have another one. Just before we go, the first one that came in, it's from Paul, saying, is it correct to say that the lines bisect each other if their midpoints have the same coordinates?
Yes, totally true. Yes.
Awesome. That's where we ended, mindsetters, unfortunately, because of time. Dina, thank you so much.
Pleasure, AB.
Right.
Good
and
stuff.
thanks to you guys also for tuning in. We love you and really appreciate. In case you just missed any of our notes, go to learn.mindset.co.za. But for today, we love you guys and we're leaving you in peace.